Our number trivia app is moving along nicely. In the previous part, we created an entity, repository contract, which is an abstract class, and the first use case, GetConcreteNumberTrivia, all using test-driven development. Today, we're going to add another use case which will uncover a nice opportunity for refactoring the code. Hello, welcome to ResoCoder, where you're getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. And as usual, be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video, all of the links, and go through this lesson at your own pace. First things first, let's refactor this GetConcreteNumberTrivia, which we have added in the last part using test-driven development. So let's actually, in addition to opening this GetConcreteNumberTrivia file, also open its test file. So over here, you can see that we have a method called execute. But did you know that Dart supports something called Callable Classes? And this is perfect for use cases because when you think about it, if we go over to the test, all that a use case does is that it has an execute method. Wouldn't it be much nicer to just call it something like this? Use case, 2 parentheses, right? Just like a regular method. The execute is really redundant here. Well, this is possible with a method called call. And we are already doing this in the spirit of test-driven development because we have first updated the test code. Now this test code doesn't even compile anymore because there is no such method. And after we've modified this test, we can now move on to the production code. And all we have to do is to rename this execute method to call. It's as simple as that. And now we've made this test to pass because the call method can be either called as a regular call method, but it can be also called without specifying the name of the call method. And now all we have to do is to use the keyboard shortcut for running all tests, which you have hopefully set up in the previous part, or you can also always go here and in the debug tab in VS Code, select Dart run all tests, and it should still pass just fine. All right, but this is obviously not all that we will do in this part, because we also want to add another use case, that is get random number trivia. That's because in addition to getting trivia for a concrete number, we can also get trivia for a random number. And the numbers API we are using for this number trivia app has actually a different API endpoint for concrete and random numbers. So this means we are getting ahead of ourselves a bit because we are not dealing currently with the data sources. We are still in the domain layer, not in the data layer. But just so you know, the numbers API, here is the API URL, so blah, blah, blah.com. And then for getting regular numbers, you have like specify the numbers, so 42, for example, and then that grants you a number. But for the random numbers, you have api.com/random. And it chooses or generates random number for you. So we will not generate random numbers directly in the get random number use case, which we are about to create. We're just going to really, again, just get the data from the repository. Should we have to generate random numbers, that would obviously go into the get random number trivia use case, which we are going to implement in just a bit, because that's actually business logic. Generating random numbers is, really simple business logic, but it's still a business logic. However, we are not going to have to do that because there is a completely different endpoint which does the work for us on the back end, so to say. But before we create the get random number trivia use case, as clean coders, we surely want our code to have a predictable interface. An interface simply means the methods and fields that are public and exposed by classes. So The current interface of the GetConcreteNumberTrivia use case is that it exposes the call method. And when you think about it, every single use case in our app or in any kind of other app should expose a call method. It doesn't matter if it gets data from a number trivia API or if it sends a space shuttle to the moon or to the Mars or whatever it does, a use case should always have a call method. And one way to enforce such a method or a stable interface of a class is to rely on the implicit, we are going to call it, word of the programmer. Sadly, and maybe it's just me, but I would say that programmers aren't well known for remembering things. Heck, I even watched some of my old tutorials because I've already forgotten how to do things I've made a tutorial on. So I have to rewatch my own tutorials. And with that, there is another way of ensuring that a certain interface is present on a class. And that is through abstract classes in Dart, because Dart doesn't support interfaces, it has only abstract classes. And basically any class can be implemented as an interface. That's something specific to Dart. In Java or in Kotlin, you would have an interface, but in Dart you have abstract class. And that way, when the abstract class, the base class for every use case, will define that it should have a call method, it will be impossible to forget that the method should be called call and instead create an execute method as we did before, because it will be enforced by the abstract class which is implemented. So let's create such an abstract class for enforcing the interface of this class right now. We're going to put it into the core folder under the use cases subfolder, because this applies to all of the use cases across all of the features of our app. That's why it goes into the core folder. So let's create a new file under use cases. We're going to call it usecase.dart, pretty simple. And inside of here, we want to have an abstract class use case. And now bear with me here, I am going to explain everything in just a little while. So it will have two type parameters. The first one is type and then params. So parameters, and this type is the return type of what else than the call function. So as you know from the already implemented GetConcreteNumberTrivia, the return type should be future, which holds either a failure or number trivia. So we go over here and we are going to call it call. Now let's import it once we've named the function, because before naming the function you cannot import anything. So let's import everything here, but of course it won't return number trivia, but it will return type. Because we are in the core folder, we cannot rely that all of the use cases will work with number trivia. We have to let the use cases which implement this base use class specify their own return type, whatever that may be. The failure can be sort of hard-coded here, so to say. It's not really hard-coded because failure is also an abstract class. Now this params type is something peculiar to this abstract base use case class. It's not all that needed right now because we aren't actually going to add any functionality to this use case class just yet. So we technically do not need this params. But why it's actually a good idea to leave it in here even though we do not need it currently is that if you wanted to do something with the parameters, so for example this int number is a parameter for the call method, and you wanted to log them in this call, so you would have a call looking something like this. So it would not be completely an abstract class without implementation, but it would have some sort of an implementation. So you would just want to log it. So print. And how would you access the number parameter passed into the call method of the GetConcreteNumberTrivia? Well, you would have a problem. You cannot access the parameter passed into the concrete class. That's where these params come in. When we specify params, you can now operate with these parameters And of course, we do not entirely need it just yet. We're not going to be really utilizing it in this app. This is probably the only thing which we are gonna do, which we don't currently need. We are not going to follow the you ain't gonna need it principle, because we are not really trying to future-proof an implementation, which is a bad thing, but trying to future-proof an interface is actually, in my opinion, a good thing. All right, so now let's go to GetConcreteNumberTrivia. And we do not need to change anything in the test for this class, because we are just really going to only implement use case and specify that the type should be number trivia. And what's up with the params? Well, we know that the params of the call method is just a single integer called number. So we technically could just specify an int here and it would be cool. And then of course, because the parameter in the use case base class is not named parameter and not optional named parameter, we would have to change this to be also non-optional non-named parameter. And let's also add the override annotation for good measure. So that would work just fine. But to make it a bit more clean again, we're going to just create a dumb data holder class, which will be called params. And this will be the case for all of the use cases. And the params class will hold all of the parameters for the call method. So in this case, it will hold only the integer number. So let's create class params, which will extend equatable. So let's import equatable, and it's gonna have just one final int number, and it's gonna be in the constructor, and it's going to be a named parameter. So let's do it like that. Let's make it required. And then let's also pass it to the super constructor of equatable. So super number, what's going on with Dart Analyzer? Let's restart it. So super constructor and pass in the number. And now before we modify the code which can be actually tested, because up until now we've been only dealing again with code which cannot be at all tested, we're going to go to the test. And now the use case should be called with params and specify params, which come from the GetConcreteNumberTrivia.dart file, and it gets a number. So again, it will be the T number. This does not compile. So let's go to the implementation. We are going to, instead of a number, accept params here, params. And then to make it all work, we're going to call the repositories method GetConcreteNumberTrivia using the params.number, which is present over there. Now the test seems to be hopefully fine, but it's not. Oh, that's right, because we have made these params to be a named argument, but in the class, in the production code, we do not have it named. So actually, let's make it not named, because it doesn't really need to be named when there's just one argument params. Naming it doesn't make any kind of sense, it's just redundant. And with that, we have the test passing. We can run it. Or not passing just yet, it's just compiling, but it's also passing, as we can see. It passed just fine. And now we have a stable interface, which every single use case in the app must conform to. With all of this work done, creating another use case for getting the random number trivia will be extremely simple and straightforward. So in the spirit of test-driven development, let's create the test first. So under test and use cases, under the domain layer test, we're going to create a new file, getRandomNumberTrivia.test. And what we can do is to just copy the test for GetConcreteNumberTrivia. You should never copy code in production, but for tests, that's different. Tests do not really have to be all that refactored. You can have some duplication in tests, but in production code, that's exactly the opposite. Of course, you should strive to not have duplication even in tests, but it's not as bad as with production code. You can have a certain amount of duplication. It doesn't really matter. So it will still have the mock number trivia repository. We are not going to deal with GetConcreteNumberTrivia, but instead GetRandomNumberTrivia. Again, we're going to get errors right off the bat because this class doesn't currently exist yet, but that's fine because we are doing TDD. Then GetRandomNumberTrivia will accept the repository as a parameter. And when it comes to the test, we do not need the test number because it's going to operate with a random number. We do not need to specify it ourselves. We're going to leave the type returned by the repository to be the tNumberTrivia. That's cool. We're going to also rename the test because it should not get trivia for the number from the repository because there is no number to get the trivia for. It's going to be gotten for random number. So the test will just say should get trivia from the repository. Then the method called on the repository will not be GetConcreteNumberTrivia, but GetRandomNumberTrivia, which doesn't accept any parameters or any arguments. And it's still going to return the successful right side of the either, because left side is failure, right side is success, so to say. And this successful side of either will contain the tNumberTrivia. And when it comes to calling the use case, now it gets a little interesting because we have params, right? But GetRandomNumberTrivia use case will not get any params passed in because there's no point in passing in parameters when it doesn't need to know about the number for which it should get the trivia because the number will be generated in the API. So it seems that we can just delete these params from being passed in and we do not get any errors, right? But that's only because the use case is dynamic. That's because the use case doesn't currently exist. So before we continue, let's just create the blank class of GetRandomNumberTrivia use case under domain use cases. So create a new file, GetRandomNumberTrivia.dart, and it's gonna be really simply a class getRandom, which will implement use case, which will return number trivia. And now comes the interesting stuff, because use case's second type parameter is params. So what are we going to specify as the type for params when getRandomNumberTrivia will not get any params because it doesn't need to get any number for which it should get the trivia? Well, we can create a class no params. And let's just also make it extend equatable, just so that two instances of no params will be always equal because they don't contain any fields. And now we can specify no params here. And now it writes here that we have an error because we do not override one method. And before we implement this method, of course, we are going to finish writing the test. So in the test, we can now see that after we import getRandomNumberTrivia, we can no longer just have an empty call for the use case because it expects one argument, and that will be no params, which specifies that there are no params, of course. The assert part of the test can remain almost unchanged because we still expect that the result will be the right side of the either, so the success containing tNumberTrivia. But what we should verify instead of getConcreteNumberTrivia on the repository, it should verify that getRandomNumberTrivia has been called. And then before we can run the test, which will of course fail completely, we have to get rid of this error that getRandomNumberTrivia use case cannot accept the repository. as an argument for the constructor. So let's go to GetRandomNumberTrivia and let's fix that. We're going to have a repository. Let's actually copy that from GetConcreteNumberTrivia because it's gonna be exactly the same. So it's gonna have the repository in here. And of course the constructor's name will be GetRandomNumberTrivia. And now this use case test does not have any apparent errors. So we can run it, but it's going to, of course, fail. And if we take a look at that, obviously the failure will be that expected write dynamic, but it received null. That's because we don't currently return anything. So let's actually implement the production code for which we have written this test. So inside GetRandomNumberTrivia, we know that we want to return await. So let's make this asynchronous. So await repository.getRandomNumberTrivia. And with that, we can rerun the test and it should pass, and it definitely does. So that's awesome. The last thing which we are gonna do is by taking a look at this noparams class, it's probably a good idea to move it over to the use case core file. This kind of a thing can be shared across multiple features because surely this GetRandomNumberTrivia use case is not the only use case which will not need any params. So because of that, we're going to cut this noparams out of here and paste it over to the use case core file, import equatable there. And now all the code will still hopefully work. We just need to import noparams in the test. If we rerun the test, we can see that it still works as it did before. And now let's just fix all of the imports. So we're going to hit F1, fix imports. This is just fix import extension for VS Code. You can find it over here. So Dart import, just download that and you will be able to also convert all of the imports to be relative imports and not absolute imports. And with that, we've just successfully implemented the whole domain layer of this number trivia app, because we have the entity, we have the repository contract abstract class, and we have all of the use cases fully implemented, and what's most important, fully tested. In the next part, we're gonna start working on the data layer, which contains the repository implementation and also data sources. So if you don't wanna miss that next part and also many more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter coding skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you with finally implementing and understanding the domain layer and also with test-driven development, give it a like and also share it with other developers who will surely benefit from it too. Follow me on Instagram, I go under the name ResoCoder everywhere if you want to get some behind the scenes news. Leave a comment if you have anything to say, if you have any questions. I try to really answer all of the appropriate questions to my full ability, and see you in the next video.